Okay, so we're going to learn what L'Hopital's rule is, and then you guys need to know when you're allowed to apply it, okay? So that's the task for today, and I believe I left an S out of here. I think he actually does spell his name like hospital, but you pronounce it L'Hopital, just so you know. What L'Hopital's rule is it's a way to find the limit of a function, but it only works in certain circumstances. But the good news is those circumstances are usually what happens anyway. So you can almost always use L'Hopital. Let's begin. So first of all, go ahead and write down this slide, please. Indeterminate means we can't come to a conclusion, okay? So, for instance, if I give you guys this, we can come to a conclusion. Does not exist, okay? If I gave you this, we can come to a conclusion. It's 0, okay? If I gave you this, we can come to a conclusion. That's infinity. If I gave you this, we can come to a conclusion. Anybody know what that is?
Infinity. 0.
2?
Undefined. Does not exist. Right next to 0.
It approaches 0, right? So these are not indeterminate. We can determine what the answers are. The ones that you've copied down here, these are indeterminate. Here's why. We know that 0 over a number is 0. We know that a number over 0 is undefined, but when you put them together, who wins? What, you would think maybe undefined, but actually not necessarily. Sometimes yes, sometimes no. It's indeterminate. You can't know. Same thing with infinity. Infinity over infinity, you might think, well, anything divided by itself is 1. But you're assuming that these infinities are the same. How many even numbers are there? Infinite. How many numbers are there?
Infinite.
Which one's more?
Neither. Undefined.
They're both countable infinity. If you want to get into more infinities.
So here's the thing. Yeah, so the point is that, that's interesting. Anyway, the point is that, wouldn't you guys agree that in any given set, there's more regular numbers or real numbers than there are just even numbers?
Mm-hmm.
So even though they're both infinity, one's bigger. Okay? And so you can't really necessarily assume that infinity divided infinity is 1. We don't know that. It could end up being 0. It could end up being infinity. It could be a lot of things. So these are indeterminate. We don't know. It turns out that those are the conditions we need to have happen to apply this new rule we're learning today called L'Hopital. Here it is. Let's go ahead and write it down. Okay, guys, so you don't need to write this, but just watch. Here's what L'Hopital's rule tells us. L'Hopital's rule tells us that if you plug in 2 to your function, if I plug in 2, what do I get on the top?
0.
What about the bottom?
0.
If you if direct substitution yields one of the indeterminate forms, like 0 over 0 or infinity, L'Hopital tells me that I can find the limit of this function by taking the limit as x still approaches 2, but with the derivative of these instead. So what's the derivative of x squared minus 4?
2x.
What's the derivative of x?
1x.
Just 1.
Yeah, 1.
Plug it in, got your limit. That's L'Hopital's rule. So if you get 0 over 0 or infinity, then you can just take the derivative of the top and the derivative of the bottom and plug in again. And you got your answer. That's it. So now we also could have solved this by factoring and canceling, right? That would work.
What if you plug in first and then you take the derivative?
You don't do that. It's wrong. But because if you did that, every problem would always be 0. Because if you plug in, you're just going to get numbers, right? And then when you take a derivative number, it's always 0. So you take the derivative first and then you plug in the number. All right. So there it is. So the limit of some kind of a fraction function, if direct substitution gives you an indeterminate form of that, then basically the limit of that function is equal to the limit of the derivative of the top over the derivative of the bottom. Okay? and then direct substitution will usually get you the answer. All right, we're going to jump into a few example problems. Let's see if you guys can just kind of figure one out really quick here. Yeah. Just a second, though. Okay, so one of these you could do L'Hopital's rule with. One of them you cannot. So I want you guys to figure out which one you could do L'Hopital with and which one you can't. And then I want you to find the limit for both. Okay, so just go ahead. For the one that you can use L'Hopital, I want you guys to actually use L'Hopital's rule. Okay, I know you could probably do it in another way, but use L'Hopital. Good. So I'm gonna say what Brody just said then. Brody identified which one L'Hopital works for. He said the bottom one. The reason why L'Hopital can be applied here is because when you do direct substitution, you get 0 over 0. Okay? So let's do L'Hopital. So L'Hopital's rule tells me, Savannah, this limit is the same thing as what? Oh, I didn't change my period block here. I still got period 2 here. You're not Savannah. Sorry. So I probably won't be calling on you then, Serena. Let me see if I can use my cards here. Christian. Christian, what? This limit is the same thing as what? There you go. And the limit of this as x approaches 3 is always 3 because it's just constant, right? Samantha, what's the limit of the top function? Which is what? Nah. It's 0. 0 on the bottom is undefined. So the answer is 0 because you end up with 0 over 2. There's your 2. Bottom. But the whole thing's 0 over 2, so the answer is 0. So this one's not a L'Hopital problem. In fact, it's just a simple direct substitution problem. But this one was. So when you have 0 over 0, that's L'Hopital. Otherwise, you're going to stick with some other strategies that we looked at. All right, so there's that. Let's go ahead and... now, here's the thing. Have you guys noticed I've been writing yields? Yeah. Okay, there's a reason for that. You don't need to write this, but just watch. Let's do the example we just had. It was 3x plus 9 over x plus 3, right? Is that right? Something like that. This will work. Now, here's the thing. A student on their FRQ one year did this. And they got the answer right. And they lost all the credit. And I think this is really stupid, but this is why they graded, okay? So I want you guys to be aware of it. Do you guys know what's wrong here? It's equal. Why is that a problem? You can't equal something that doesn't exist. Equals means it's a value. This is not a value. And I don't know why they're so picky about this stuff. But if you write this, they're going to get you, just so you know. So don't write equals 0 over 0. Don't write infinity over infinity. As a matter of fact, I've even been told not to write equals infinity. Remember we did some problems yesterday? And I said the limit equals infinity. I've been told maybe not to do that too. Because technically, infinity is not a value. It's a direction you're going. Right? So, yeah.
It's like pulling out, I don't know, can you, on like on like the SAT essay. It's like if someone was grading the SAT essay and they said, I don't know, can you?
Yeah, it's like a technicality. And they know what you mean. And that's why it's frustrating. The first time I heard that, I was like, that's dumb. Like, they literally didn't give the kid any points. And it's like, are you freaking serious? But that's what they're going to do. So I just want you guys to be aware, so now we know, and we won't make that mistake. Yeah? Are you raising your hand? Okay. All right. So now here's what I want to do. I want to show you guys the best way to write your answer. Okay? So that's what it's going to be. This is only for FRQ. I'm only going to do it once because it's very lengthy. The purpose of L'Hopital is supposed to be fast, easy, and done. But the way they want you to write it on here, they make it really long. So I'm going to show you guys how you should write your answer on an FRQ. After that, we're going to treat the rest of today's problems like multiple choice, where it's just bada bing, bada boom, here's my answer. Okay? But I want to show you what they want you to do. So go ahead and write this down. How to write on FRQ. Ready? Okay, so the limit as x approaches -1 of x squared plus 5x plus 4 over x plus 1. Now, we could do this our old school way, by the way. You could just factor and cancel. But we're practicing L'Hopital today, so we're just going to stick with L'Hopital. So first of all, what they want to see you do is this. They want you to say, this is okay, you can draw an arrow. You can say they want you to know that the limit as x approaches -1 of the top, they want you to verify that that's 0. Then they want you to verify the same thing for the bottom. Notice we didn't say the fraction equals 0 over 0. What we're doing is we're saying the top equals 0, the bottom equals 0. And writing the limit is good because that's a property of limits. Remember how we said when you take the limit of a fraction, do the limit of the top and the limit of the bottom, so you write that separately there. So there you're following all their little picky rules. And there it is. Now, since I got 0, 0, here's a great sentence to write. Because you don't want to just jump right into L'Hopital. You want to say, since the limit as x approaches -1 of this function yields 0 over 0, we can say now at this point, because you're in a rush and you're trying to get done with the test, you probably just want to say the limit and then put the derivative. But technically what you should say this limit is equal to this other limit with the derivatives, right? So we could say that the limit of our original function here is equivalent to the limit of the derivative of those two pieces. And then you can go ahead and do your direct substitution and get your answer. Okay? So that's the proper way to write your answer on an FRQ. -2 plus 5 is 3, so we're good. But there it is. So you're using the property of limits to find the limit of the top and bottom. You're verifying that both of those are 0. And then you're stating that because this limit does in fact give me an indeterminate form, that's a criteria. If that doesn't happen, you can't do L'Hopital. So you have to state, since this is happening, my original function's limit is equal to this function's limit. And that's L'Hopital's rule. And therefore my answer is this. So that's like the most complete way you could possibly answer. Now I'm not going to do that on every problem today. It's an extreme waste of ink and time, right? But you want to know how to do that for an FRQ. Okay. Does anybody feel they would need to practice writing it so formally? Like if I gave you just another problem, just how to format it. Okay, let's throw one at you. The arrow's okay. It's not an official math symbol, but it does indicate that you could actually even not have those arrows there. They don't need them. The point is you said the limit of the top is this. That's good enough. So you don't even need the arrows because an arrow is not an official math symbol, and so Yeah, you don't want to be making up math symbols that don't really exist. Oh, there's an arrow, but that one means something, right? That means we're approaching. All right, so if you guys want to practice writing it, there you go. I'll give you a few minutes to write that one out, just so you can know. That's the end of the tedious expression. Now we're going to actually use L'Hopital, what it was meant for, to make problems faster and easier. But before we do, we got to review a little bit of trig, because I decided to start getting some, like the ones we did earlier today, super chill, right? You guys know how to do that. I want to take this opportunity to review some trigs, LNs, and E's with you guys to apply L'Hopital to those as well. And that's actually just all we're going to be doing for the next 3 days. We're going to be using L'Hopital on various functions and looking at various outcomes. So first of all, let's review a little bit, you guys. Can somebody tell you what is sine of 0?
Zero.
Oh, so I gotta write
One.
Okay. How about this? What is the derivative of sine?
cosine.
One.
That one. How about this?
Sine.
Negative sine.
Negative sine.
Okay.
Wait, isn't it technically like 1 though? Because if cosine is 1 and the derivative of sine is cosine, then isn't that 1?
Because I think you're doing what you talked about earlier. Remember how I said derivative first, then you plug in? I think you're plugging in and then doing derivative maybe. But you're right. They're very close. I see the connections you're making, but not quite. How about this? What is the derivative of cosine of 3x? Now this is a chain rule, right? So what's the derivative of the outside?
Negative sine.
What's the derivative of the inside? So how would I write my final answer?
Negative 3 sine.
So in other words, just, switch it and put the number in the front. You just got to watch out for the negative, right? What else should I throw at you guys? This one's going to come up too. What is, let's say secant of, let's do secant of 0. Well, secant is what? It's the reciprocal of?
Cosine.
Cosine. Yeah, darn trig. All right. And what is cosine of 0? We've already talked about that.
1.
So this is 1 over.
1.
Okay. So we want to review our trig. We want to know what that is. Let's actually jump in and do some problems now. So now I'm not going to use the formal way to write the answers for the rest of today's problems. I'm just going to be kind of quick and dirty about it. But we don't want to develop any bad habits either. So I'll try not to write anything that's wrong, but let's try not to show more than I need to. So here we go. Let's start with this one. Number 1. The limit as x approaches 0, write this with me, tangent of x over 3x. Okay. Now, I'm going to write something that I don't think they can ding you for, but I wouldn't do it on an FRQ, but it's great for multiple choice. I would not write things incorrectly when you're working out things for multiple choice either, because then you're developing a habit, and guess where it's going to end up? On your FRQ. So just don't write things wrong, okay? But here's a ghetto way to do it. Plug 0 in there, what do you get? Top. Plug 0 in there, what do you get? Okay, there we go. Does L'Hopital apply?
Oh, yes.
Yes, it does. Now, technically, I should say that this equals the derivative, but I'm not going to. I'm just going to do this now. The limit is, what's the derivative at the bottom? Derivative of the top?
Cosine of x tangent. Oh wait, x. Cosine of x.
Just
X secant squared.
Oh yeah.
Wouldn't it be X times secant squared?
No, because, well, if you want to think of chain rule, right? Derivative of tangent is secant squared, right? But derivative of the inside would just be 1.
Oh.
So, okay, so let's do this. Now, plug that in. What do you get? We already talked about this. What's secant of 0? It was 1. And it's being squared, so it's 1. So we have 1 over 3. There you go. That's your limit. Bueno? Let's do another one. How's about... limit x is approaching 0, cosine 3 pi over 2 plus x over x. Okay, now this one I didn't prep you for. Here we go. Bottom, top. Well, if you plug in 0, you get cosine of what? Which is what? Take a wild guess. It's 0. All right, because otherwise we can't do L'Hopital, right? But if you want to see why, where's 3 pi over 2, guys?
In the center of the circle.
Nate was right. It's over there. You guys got it? It's right there.
Oh, it's right
Now,
I said that in the center.
cosine is the x value. What's the x value?
0.
There you go. All right, so L'Hopital works, right? We don't want to just assume that, but it does work. Now we do our derivative. What's the derivative of cosine?
Negative sign.
You're right, good. Don't change the inside, though. But what do we do to the inside? Take the derivative of it. What's the derivative of that? 0. It's a number. It's just a number. Doesn't look like 1, but it is. How about this one? 1. So I'm going to multiply by 1. Doesn't change anything. All right, bottom, plug in. Final answer is 1. Here's why. When you plug in 0, that's back down here again, right? 3 pi over 2. Sine is negative 1 down there. So we have a negative 1 with a negative in front, which makes a positive 1. Okay? Okay. Let's do another one.
Wait, don't erase
This one has an interesting little twist to it. Ready? Here we go. We have limit x approaches 0, 4x squared over 1 minus cosine 5x. Okay, so what's the top make? 0. Bottom? L'Hopital? Derivative of the top? Okay, derivative of the bottom.
Is that a 5x?
Yes.
Like
The 1 goes away. So really we just need to do the derivative of negative cosine. What's the derivative of negative cosine? It's going to be positive sign because the derivative of cosine is negative, but since there's a negative in the front, it becomes positive, right? Don't change the inside, but we do multiply by the inside derivative, which is 5. Make sure your 5 doesn't look like an S like mine does. All right, now, direct substitution, right? Top, what do you get?
0.
Bottom? Uh-oh. It's indeterminate again. Guess what?
Do it again.
L'Hopital again. You could do L'Hopital an indefinite number of times. Just keep doing it till you get to the end. Okay, so let's do it again. Limit x approaches 0. What's the top going to be? The derivative of the top is 8. Derivative of the bottom. Let's see. What's the derivative of sine? Cosine, right? Don't change the inside. But we do want to multiply by the derivative of the inside, which is,
25.
it's going to be 25. The derivative of the inside is 5. And now we do our direct substitution. So what's cosine of 0 going to be?
So all you do is take like derivatives and make everything 0.
Kinda. Just got to make sure you're making things 0 at the right time. Like she just made cosine of 0 is 0 and its cosine of 0 is 1. But yes, got to be careful. So the answer is 8/25. Yes, my son. Okay. Let me throw a couple at you. Here we go, number 1. We'll start with something chillax. Limit x approaches 0. 1 minus cosine x over x. That's number 1. Number 2, let's take it up a notch. How about the limit as x approaches 0 of sine of 2x over 3x, and then finally we'll take it up to a third notch. There you go. Weird right now. I think I'm going to stop that joke. All right, Ryan, what'd you get for number 1?
0.
I agree.
Because isn't it 1 minus negative sign, which is technically positive sign, over 0, so it's going to be 0.
No, we take the derivative. The top is sine, and the bottom is 1. And then when you plug in your 0, sine of 0 is 0. So that's your derivative you should have gotten after you did your L'Hopital rule. Dylan Booz, what'd you get?
2/3.
That's right. The derivative of the top would have been 2 cosine 2x. The derivative of the bottom would have been 3. Direct substitution makes this become 1. And so you're left with 2/3. Last one, Brody, what did you get for number 3?
0.
Did you do it, Brody? It's okay. This one's going to take some time because if you didn't work on it, it'd be kind of hard to do it mentally. Yeah? Negative 1/9 is right. Now let's see why. Okay. The derivative of the top, well, first of all, direct substitution gives you 0 over 0, right? But if you take the derivative of negative cosine, you get sine, right? Take the derivative of the bottom, you get negative 3 sine 3x. But guess what? Direct substitution gives you 0 over 0 again. So we need to do L'Hopital again. So the second time we do the derivative, we get cosine x over negative 9 cosine 3x. And when you plug in your 0, this is 1, this is 1, so you're left with negative 1/9. Hello, Dee. Okay, sounds good. All right, let's do something else. That was Aaron's mom. Aaron Johnson is not here today. All right, she works on our campus. All right, let's review a little bit. We're very low on time, so I probably won't get to do too many examples like this, but I just want to refresh your guys' minds of a few things before I set you loose on the homework. You ready? First of all, what is e to the 0?
E.
1.
1. All right. Next, what is the derivative of e to the x?
Oh, e to the x.
E to the x. What is the derivative e to the 3x?
3e to the 3x.
So the derivative of the outside is this. The derivative of the inside is 3, right? Okay. So you'll be doing some derivatives of e functions tonight, right? What about ln's, though? What is ln of 1? You would like to think so. But guess what it is?
0.
0. These are actually the same statement, just written as inverses. This is e to the power of 0 equals 1. What's the derivative of ln of x?
1 over x.
What is the derivative of ln of 3x?
1 over 3.
Close. 1 over 3x times 3. And those just cancel, so guess what? 1 over x also. How about the derivative, you'll see this one on the homework, of ln of x squared? Close.
2x squared.
Good. So the derivative of ln is 1 over x squared, right? But we need to multiply it by the derivative of x squared, which is 2x. And so you end up with 2x over x squared, but that can be simplified to what? So those are some things that you'll need in order to do some of the other L'Hopital problems tonight on your homework. I'm just going to start working some out in case you guys want some examples to look at tonight on your homework, but there's only 2 minutes of class left. So you guys are welcome to pack up, and I'll just work them out, and I'll keep working after you guys are gone. I'll post them if you want to look. I'm just going to do about 2 examples for you, okay? Okay, honey. We'll go watch the Wheel of Fortune afterwards. Go to Marie Calendar to get some pie.
I am hurt and offended and angry.
Did you bring the crossword puzzle? I need something to do while I wait for our waitress. I'm sorry.
I remember last year when you were my favorite teacher and you didn't make me.
Yeah, I don't know what happened. Okay. So direct substitution gives me e to the 0 is 1 minus 1, which is 0. And we already know this one is 0. So we do our derivative. The derivative of this is 3e to the 3x. The derivative of 1 is gone. And we already know how to do this as well. Direct substitution. This is 1. If you plug in 0, you get 1. So 3 times 1 is 3. Direct substitution here, this is also 1. So 3 times 1 is 3. And therefore the answer is 1. Let's do another one. The limits. As x approaches -1 of 4 ln of x squared over x squared minus 1. All right. So direct substitution gives me 4 ln of -1 squared, which is 4 ln of 1. Now this is 0, and 0 times 4 is 0. Direct substitution here, I think we all can see clearly that is 0. So L'Hopital applies, and we'll do the L'Hopital rule. Okay, so the derivative of the top would be 1 over x squared times
Let me take a picture of that really quick, because I know why she's
2x. I'm recording.
Oh, my dumb self.
Goodbye, dear. Have a good day. Times 2x. The derivative of the bottom is 2x. In this case, the top can be simplified a little bit. So we have 4 times 1 times 2x is going to be,
Again,
You got a 2 last
that was the stupidest 2 of my life.
8x over x squared, right?
All I had to say
Over
was
2x. And then this can be reduced, right? We can take an x out, so you're left with 8 over x. Although you really don't need to do all the reducing. We could have just plugged in and simplified after we had the numbers in there. Let's go ahead and just plug in now. So if I plug in -1 here, I end up with -8 on the top. Plug in -1 here, I get -2 on the bottom. Final answer is positive, not -4. So same process, just different derivatives.